Hello everyone. We are Team Think Tank. We are presenting our product Digital Parker, which is a parking slot detection and occupancy monitoring system. What is our product? Our product can detect and monitor parking slots. It can detect the data in real time as well. So why do we need this product? First is it is efficient. Yes, it is efficient to optimizes parking space utilization. Second, it is cost effective. It reduces the need for ground mounted sensors and manual monitoring. Third is it it is it needs lower maintenance cost than traditional systems. Fourth, accuracy. It is accurate. Uh, it can minimize errors associated with manual monitoring. And last but not the least, it, it can detect fire. Who is this product for? This product is for parking facility operators where they can improve their management for parking spaces. Next is for drivers where they can easier and quicker parking spot detection. Third one is for urban planners for their better planning and utilization of urban parking infrastructure. Fourth one is for security personnel where they can enhance their monitoring capabilities with digital Parker. Last but not the least, fire department where they can early detect the fire, where they can prevent the significant damage and improve their safety.
Now I will talk about the components of the system. So first component is the NX Meta desktop. Then there is a NX Meta server, which we all know. In that server, we have used the AI plugin, the NX AI plugin, and then with addition to that, we have also used the ROI plugin. We have also implemented a post processor, which basically takes up the results from both of them and sends it to the web application. There is a new model which is added now, which is the Fire model. We will go through the web app, and then we can also see the notifications in the mobile application. So for the demo, I will walk through the code base. It is publicly hosted into this URL. And first I will go through the demo video, and during that I will also go through the code base one by one. So let's see the demo first. Here I have recorded the demo with the given repo. The same repo I have also used this post processor Python example. This Python example code base is all there in the repo. So what we will do is we will go to this repo where we have this particular link of the front end, and in the folder of front end we will run the application of our essentially the web application. So that is active now. Now we will open up a sample RTSP which contains the video. We will go to the application of NX Meta, and here if you can see, now the camera is active, and also you can see the ROI plugins. Right. Let's select, instead of all models, so we'll select the 80 class model, and we will select the given post processor. Alright, so now they are coming up. So it seems that the model was selected wrong. So we have now switched to the 320 cross 320 object detector model, which was again given by the meta repo. Now as you can see, the spot one is occupied, which is true in our case. The spot one is really occupied by a truck, or right now it's like a big SUV. As you can see, there is a spot 2 and spot 3 with different colors. And as we can see, spot 4 is also occupied, which is the yellow color. Now the spot 5 we have marked it as a parent parking or maybe a disabled parking in some customer use cases, so that is also occupied. As we can see, the time occupied is also increasing one by one and every second. Now the video is again empty with having the spot 1, so you see that the status is vacant and the overall status is also shown, which is basically right now 40%. So from all the 5 spots there is a 40% chance that the parking is full. There is a heat map also which is given, so it's used for collecting the data over the long period of time, so that is done. So now the truck or the SUV in our case is backing up from spot 2 to spot 1, and now as you can see the occupancy is getting occupied. Yeah. So let's stop this particular plugin from this camera, and now we have one more use case, so we'll look into that. So one more use case which we explained earlier in our demo was a fire detection use case. So we'll move on to a new layout, and you can see that the camera is offline now. So what we'll do is we will again make the RTSP stream work for the fire camera. So here I am enabling the fire MP4 file which contains that video, and now that particular video is converted to an RTSP link which now catches up into the NX desktop application. So here we will check the camera settings and we will check what is the plugin which we have deployed. So we have seen an AI manager plugin here, and as you can see there is a new model which is added, which is the fire model. So this is a custom model which we have added for this particular hackathon. Now this fire model is again deployed into the current repo which we have shown in the demo. So in this particular fire smoke underscore scalable repo, you can see all the files are present. So we have created a virtual environment, we have installed all the requirements file, we have exported this PyTorch model to the ONNX model, right? And then we are able to see some results from that particular ONNX model. So once that ONNX model is built, which in our case is fire model ONNX file, we are able to upload it into the EVOS code base. So as we can see in the dashboard where the models are listed, we basically have added a new model which is again accepted here. So this is fire model, and we have used the add model technique. So once we go to the available models, as we can see there are 4 listed models now with our detector model also, and then there is a fire model. So now once let's go and see this model. So we have used again like a off-the-shelf model which is basically trained on wildfires and open areas fires, and as we can see it is going to give out the bounding box. So this fire model is now selected here, and let's start again the AI manager plugin. Alright, let's see if the objects are getting drawn. Alright, so now the bounding box of fire came up for some time. Yeah, it is coming. This demo is getting recorded, that is why the manager seems slow. But if we are not recording the screen, we will be able to see the detections coming out for that area of the fire where in the video there is a fire. So as we can see, this is a sample parking lot, and then we have a fire detection as well. So we will now set a camera rule for this particular model. So we'll add the rule and we will add a analytics object group. We will select it for the fire camera. So now for that firmware, as you can see, you have an object type which is shown as fire, and we will click on OK just to apply that rule. So now we can see that there is a notification which is in our desktop which is shown as fire, and here we can see what is the time of that particular detection, where the source of that particular detection is, and now there is a thumbnail for that particular file. So this basically completes the loop of having something on the camera and then directly to the plugins as our alerts. So with our new trained model, the fire is getting detected. So now I will stop the demo for now and basically go through the code base. So here we have trained a new model which is for the 3-class model for fire and smoke and the default class. And as you can see, the training is taken up on a wide known data set of screenshots and news. We have achieved about 89% and 87% accuracies for smoke and fire. And if we see the model, which is now dumped into this particular repo. So here I am going through the code base of that particular hackathon. So here in the fire smoke scalable folder, we can go through each and every file and see the changes which we have done for the model to run. So as we can see, we have made the classes of fire, default and smoke, and then we have added the pre and post processing functions, which are again given by the NX meta repos. So we have also simplified that ONX file for our upload to be successful. In this particular code base, we can see that there is a front-end code base for our UI, which we have seen in the demo. And then there is a post processor which we have again used for sending the alerts to the front end. There is a test folder also which contains all the testing files which we were able to use for a particular video and see how the demo will work. So this is for about the hackathon's demo. Hope you have liked it, and do post any doubts if you have about this particular implementation.